Welcome back. The standard error. Hey, nothing standard about what we're doing, but it's one of these slightly tricky things, but it's right at the heart of everything, and there's a picture, so it's really dead simple. Well, here we have the population. Let's take the dance of the means. There they go. Let's turn on the mean heap, and there it is building up. So what is this heap? It's the sampling distribution of the sample mean. What does that mean? It just means we take a whole lot of samples, pile up their means, and there is the heap. And it's called a sampling distribution, of course, because, you guessed it, we produce it by sampling, taking a whole lot of samples from our population. So there we've got about 254 means making this mean heap, like so, called the sampling distribution of the sample mean. Now, the standard error. Close the door, lower your voice, and I'll let you into a secret. Up in the population, I can turn on these lines which, as you remember, mark standard deviation units. Well, this distribution down here has its own standard deviation, and I can turn on lines here to mark it. There's the mean of the sampling distribution, which is lined up with the mean of the population, and that's always the case, these simple mean situations. And here are the standard deviation units of this sampling distribution. Check this. Look at -2 to +2 of those units between that line, and we've got most of the values in this distribution, just a few little odd ones out at the edges. Well, this standard deviation of this special distribution is called the standard error. So it's simple, really. The standard error is the standard deviation of the sampling distribution of the sample mean. Got it? Repeat after me. The standard error is the standard deviation of the sampling distribution of the sample mean. So now, if somebody at a party mentions, hey, standard error, you don't have to get tight in your stomach. You just think, yeah, I know about that. Yeah, mean heap, green heap down here. Just sort of a measure of the width of the mean heap. Simple. Okay, question. Suppose I took larger samples, say n, the size of our sample, n equals 80 instead of 20. Will this sampling distribution be narrower or wider? Narrower, of course. Bigger samples give means that are closer to the population mean. So for bigger samples, will the standard error be smaller or larger? It'll be smaller, absolutely right. And I'll leave it to you to download the software and run this and convince yourself that yes, with n equals 80, you get a standard error that's actually about half the size of what we get with n equals 20. Multiply the sample size by 4 from 20 to 80, and you halve the standard error from what it is here around about 5 maybe, bit less, 4.5, down to about 2 or 2.5, something like that. So here we've got standard deviation up in the population, which is 20. And of course, when we take bigger samples, that doesn't change. The population just remains the population like this. But the standard error down here gets smaller if we take larger samples. One last idea. I'm going to turn on these two heavier lines there. And they're positioned so that they capture 95% of the area under this sampling distribution curve. In the long run, they'll capture 95% of the sample means. So where are they? They're pretty close to 2 standard errors above and below the mean. And we call this distance, that's about 2 standard errors from the mean out to this line, we call that the margin of error, MOE, the margin of error, because it is sort of the maximum likely difference between a sample mean and the population mean. That's pretty tricky, I'll say it again. We call this distance here from the overall mean out to these lines, the margin of error, because that distance, about 10 here, about twice the standard error, is the maximum likely difference between a sample mean and the population mean. There are a few oddballs. Here are a few means that are a bit further out than the margin of error, and a few down here, but 95% of our means are within MOE, M-O-E, of the mean. Very handy margin of error. Bear it in mind, there will be more. And let me show you this picture once again, just to remind you that I'm using the ESCI software, and you can download it from thenewstatistics.com. It runs under Microsoft Excel. There are 3 versions for different versions of Excel, including a Macintosh version.